welcome back, and today's our second experiment, and it's all about buoyancy. It's very exciting, right? I'm excited too. Last time we experimented the porous and non-porous materials, and now we're going to experiment about buoyancy. And buoyancy is the sinking or the floating of an object. Okay, so I got my materials here. I got my pitcher. I got my marbles. These are my marbles. I got my baseball. I got my ping pong balls also. I got my pellet guns. I got my foil. And I got my needles plus my styrofoam. I got my leaf, and I got my comb. Okay, this is a plastic comb, okay? Plastic comb. Okay, so now let's get started. Okay, so now let's start our experiment. First is this plastic comb. Guess whether it will sink or float. Let's try. Oh, it wasn't floating nor sinking, because the floating is above and sinking is below. So it's neither above or below, it's just a little bit tad over, but it's only in the middle of the water. Why is it in the middle? Because its weight is same or equivalent amount with the water buoyancy. Okay, so now let's move on. Our marbles. So here's our marbles. Guess whether it will sink or float. Okay, so if you said sink, yes, you are correct. Okay, yeah, right, it's sinking. And not only that, it increases the weight of the marbles. It increases the level of the water. A while ago it was here, then now it turns over here. Okay, so let's try all these marbles. We will put it here. 1, 2, 3. Okay, so as you see, the weight of the marbles, a while ago it was here, then it goes here, then it increases over here at this line, because the weight of the marbles increased the water. So now let's move on through our needle. This is our needle. Be careful. Guess whether it will sink or float. Okay, so let's see your answers. Oh, it's not floating over here. It's down below and you can't see it. See, look at the water and nothing's floating over there, some needles. So it sank down there below. Because even though it's light, don't judge. We need to experiment first before we judge. Because look at the needle, even it's light, it sank. Okay. Next is our styrofoam. Of course, I'll ask you again if it will sink or it will float. Of course, the one who said float is correct. It's floating down there. See? Next is our foil. Here is our pieces of foil. Check whether it will sink or not. Okay, look at the foil. I put the foil down. At first you see it's floating, right? But when you move, some others are sinking. Or let's see, we can touch it. And it sank below because the water occupied its floating space. Yeah, so it sank down below is what we see. Next is our ping pong balls. This ping pong ball. Yeah, of course, I didn't ask you whether it will sink or float because I wanted you to see if it will sink or float. So this floated because it's only a light one. Okay, next is our pellet guns or pellet guns. This ones. So I got 3 pieces here and watch whether it will sink or float. No judging. 1, 2, 3. Oh, it sank quickly. Watch again. And for the 3rd time. It sank because even though it's light, it's still sinking. That's why don't judge whether it's light or not, heavy or not. Maybe the light's sinking and the heavy is floating. I'll explain that to you later. Now, this is our baseball. Okay, let's see our baseball. Guess whether it will sink or float. Okay, now I'll try. Oops. Oh, it's floating. So even it's heavy, it floated. So it's floating even though I tried to force it down. Come on, go down. It's not going down. Yeah, right. Okay, so guys, the trivia and the fact I'm going to tell you. Why not all materials that are heavy are floating? Why sometimes all heavy materials float? Like this baseball, it floats. Why this kind of pellet guns or these marbles, they are lighter than this baseball, but why is it sinking? And this one is sinking also. See? It's sinking. So it is because of the density. The density is not depending on the weight of an object or a material. It's based on the quality or the quantity of the mass per volume. Or in short, we have the specific gravity. Why this heavy thing floats, but why this lighter object sinks? Or maybe this small thing, that's really small, why did it sink? Or even this needle, why did it sink? It's really light and the lightest among all of them. And even you put it on the scale, it's not kitchen scale or weighing scale. It's not moving any of the scales at all. It's still the same, but why did it sink? Is it really heavy? No, because of the density. It has its own gravity. Because this one, of course, as you see, it's a metal, and this styrofoam is only a light thing. But this one, maybe there's something composed that make it sink even though it's a light thing. Or this marble. Yeah, right. Okay, so there's also a pressure in this thing. That's why heavy objects float. Light objects like these. Some others of light objects float. Some others like these sink. And we call that the mass per volume, or short, the density, the specific gravity of an object. Okay, so that's the whole experimentation of buoyancy. Now, after we have a hard work study, I'm going to have a surprise for you. we're going to play. And I got my extra water here. What is that? Let's see. Ta-da! It's a paper boat. So let's see the paper boat. Okay, now let's play the buoyant floating things around the world. Let's try this and that. And this is their seal. Yeah, right. Okay, now I got my fan. Yay! Roll, roll your boat gently down the stream. Merrily, 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 merrily. Life is but a dream. Yeah. That's the buoyancy. Okay, so they enjoy traveling all around the world. So, that's it. Thank you for watching. Bye. God bless. See you soon. Mwah.